Welcome to our video lesson on the Pythagorean Theorem. You've already been introduced to the Pythagorean Theorem with activities we did earlier, but we're going to talk about how to apply it and how to use it in different situations. Let's start with a quick reminder about the Pythagorean Theorem. Remember that Pythagorean Theorem is true for right triangles. Those are triangles with a right angle in them. Also remember what it is. It's that the square of each of the legs, so the square of this side here, which is this square here A, plus the square of this side here, side B, so this square, when you add them together, they are equivalent or equal to our red square over here. And algebraically, we can write that as A squared plus B squared is equal to C squared. And if you look at the different squares, the green square plus the purple square is equal to the red square. Okay, let's look at how we can use this theorem in some math problems. The first one, a triangle has side lengths of 5 centimeters, 7 centimeters, and 9 centimeters. What is the area of each square that can be drawn on the three sides of the triangle? So the first question is asking is for us to find the area of each of these squares. And if you think back to our previous slide, we can find the area by squaring each of these side lengths here. So if we have a side length on a triangle, so let's pretend our triangle looks like this. We don't know if it's a right triangle or not. We have a side of 5, a side of 7, and a side of 9. We need to find the area of the square on the side, so that would be this square right here. To find that, we multiply the one side length, which is 5, by the other side length, which is also 5, to get the area. So in this situation, our area would be 5 squared. And we know 5 squared is equal to 25. This is measured in centimeters, so that would be 25 centimeters squared. Alright, what about our next side? We would have 7 along one side, and then another 7 down the other side, which would end up making a square. So this would be 7 times 7, which is the same thing as 7 squared, which is equal to 49 centimeters squared. Alright, the last side here has a length of 9 centimeters. So the square would be 9 centimeters by 9 centimeters. To find the area, we would do 9 squared, which would be equal to 81 centimeters squared. So the area of each square that can be drawn on the three sides of the triangle, the first one is 25 centimeters squared, the second one is 49 centimeters squared, and the last one is 81 centimeters squared. Okay, our next question is the triangle a right triangle? Explain your answer. Now remember that for a right triangle, the Pythagorean theorem is true, which means the a squared plus b squared is equal to c squared. Now you may be thinking, wait a minute, I don't see any a's, b's, or c's in this triangle over here. Well, these are variables, and they represent our different side lengths. Remember that the c represents our hypotenuse, which we've talked about, and it is a special side on a right triangle. It is always the longest side. So if this triangle is a right triangle, that means my c squared would be 81 centimeters. And the question that we're being asked is 81 equal to the other two squares added together? So is that equal to 25 plus 49? And I put a little question mark up here because we're not sure. We're trying to see if it's equal. So let's add 25 and 49 together. 5 and 9 is 14. 1 and 2 is 3, plus 4 is 7. So I get that the sum of this side is 74. And that is not equal to 81. So that means that this triangle is not a right triangle. because the square on the sides, the squares of the sides, do not add up to the square of the hypotenuse. Okay, let's look at another example. The next question is the same as our last one. A triangle has side lengths of 12 centimeters, 16 centimeters, and 20 centimeters. What is the area of each square that can be drawn on the three sides of the triangle? So the first question is just asking us to find the area of each of the sides of our triangle. Now I'm going to draw a quick sketch, oh that's not very straight, of our triangle and label the sides just to help us. So I'll make this 20 centimeters, 16 centimeters, and 12 centimeters. So this question is asking us about the area on the sides of the square. So let's start with 20 centimeters. The area would be 20 times 20, or 20 squared. And I'm going to do that over here. 20 times 20. 0 times 0 is 0, and 0 times 2 is 0 as well. I add a 0. 2 times 0 is again 0, and 2 times 2 is 4. So this gives me 400. So that means 20 to the power of 2, or 20 squared, is actually 400. And we have 20 centimeters times 20 centimeters, so our centimeters actually end up being squared as well. Okay, let's do 16 next. 16 centimeters on one side of a square with another side of 16 centimeters would have an area equal to 16 times 16. So let's do that over here. 16 times 16. 6 times 6 is 36. 6 times 1 is 6, plus 3 is 9. Add the 0. 1 times 6 is 6, and 1 times 1 is 1. Find the sum. 6 plus 0 is 6, 9 plus 6 is 15, and 1 and 1 is 2. So I have that 16 squared is equal to 256 centimeters. So that means the area of this side here is 256 centimeters squared. And the last side is 12 squared. Now I know this one off by heart. 12 squared is 144 centimeters squared. Okay, the next question says, is the triangle a right triangle? Explain your answer. Well, in order for it to be a right triangle, the relationship a squared plus b squared is equal to c squared must be true. Now remember, c squared is my hypotenuse, so the longest side, and in this case it would be 400 centimeters squared. So this would be 400 centimeters squared. Okay, and a squared plus b squared will be my other two sides. So let's make a squared 16. So this would be 256 plus my last one is 12 squared. Now the question is, are these two equal to each other? If they are equal, then it is a right triangle, and if they're not, then it isn't. So let's check over here. What's 256 plus 144? 6 and 4 is 10. 5 and 1 is 6, plus 4 is another 10. And then 2 plus 1 and 1 is 4. So that means that 400 is equal to 400. So the sum of the areas of these two sides is equal to this side, which means that this is a right triangle. And we can write that out. This is a right triangle because the sum of the squares up of the legs, that's what the other sides of the triangle are called, not the hypotenuse, but the legs, is equal to the square of the hypotenuse, and I'm just going to write HYP. Alright, let's look at a different type of problem now, not identifying if it is a right triangle or not, but instead determining an unknown side length of a right triangle. So we know that this here is a right triangle. We need to determine the length of hypotenuse C. Express your answer to the nearest meter. Your handout might say to the nearest tenth of a meter, but we're actually going to do it to the nearest meter. Alright, to start we write down the Pythagorean theorem that a squared plus b squared is equal to c squared. Alright, let's look here. The side length A is the side right here, and it has a length of 7 meters. So instead of writing A, I'm going to replace it with 7. Now this is still going to be squared plus, now B here is this side length here and is 10 meters. So instead of writing B, I'm going to write 10. And I don't know what C is, so I'm just going to leave it as C squared. Alright, I know that 7 squared is 49, plus 10 squared is 100, and that has to be equal to C squared. Now 49 plus 100 is 149, and that is equal to C squared. Well, we don't want C squared. We don't want the area of the whole square off this side. We want the actual length of C. That's why it says to the nearest meter. So this is C squared. C squared is equal to 149, but we just want C. So what we're going to do is take the square root of each side. That will cancel out this C, and the square root of 149 is equal to C. Now using our estimation, we know that this isn't a perfect square, but it's going to be close to a perfect square. I know that 12 squared is equal to 144, and I know that off the top of my head. Well, my question is, what's 13 squared? So we need to check what 13 times 13 is. 3 times 3 is 9, 3 times 1 is 3, 0, 1 times 3 is 3, 1 times 1 is 1, and I find the sum, 961. So 169. So that means that our square root is in between 169 and 144, but it is closer to 144 than it is to 169. So that means that to the nearest meter, my square root here, C, would be 12 is equal to C. And I'm going to add this little dot up here, which means approximately, so that people know that it's not exactly equal to, and we guess. So that dot's very important because it's not an exact answer. The last thing I need are my units. Now it's not 12 monkeys or 12 apples, it's 12 meters. So I need to make sure I put 12m is approximately equal to C. Alright, let's look at another problem here. This says, what is the length of leg E of the right triangle? So we know again that this is a right triangle. Instead of having A, B, and C, in this situation we have D, E, and F. But the same relationship holds true. The square of side D plus the square of side E has to be equal to the square of side F. So let's write it that way. We have D squared plus E squared has to be equal to F squared. Now I can sub in my different side lengths. So I know that D is equal to 9 millimeters. So instead of writing D, I'm going to write 9. Now I don't know what my E is, so I'm going to leave that as a letter, a variable, E squared. And then my last one is F. F I know is 41. So F 41 goes here for the F, 41 squared. Alright, now I need to try and make some of these simpler. Well, 9 squared is 81. 41 squared, I don't know off the top of my head, so I'm going to do that over here. We have 41 times 41. 1 times 1 is 1, and 1 times 4 is 4. Add my 0. 4 times 1 is 4, and 4 times 4 is 16. Now we find the sum. 1 and 0 is 1, 4 and 4 is 8, 6, 1. So that means that 41 squared is 1,681. Now we need to get this e squared by itself. To get e squared by itself, I'm going to subtract 81 from both sides of my equal sign. That will cancel out this 81 over here and leave me just with e squared. Now I have 1,681 minus 81, which gives me 1,600. Now I don't want e squared, I don't want the measure of the area of the side, I just want the side length here, sorry, this one. So that means that I need to take the square root of both sides to get just e. So e is equal to whatever the square root of 1,600 is. Well, this should look familiar to you. We know that the square root of 16 is 4. So this is actually 4 plus 2 zeros, which tells me the square root is going to be something with a 4 in it. Let's see what 40 times 40 is. 0 times 0 is 0, and 0 times 4 is again 0. So that's my first line done. I add my 0 down here. 4 times 0 is 0, and 4 times 4 is 16. So when we find the sum, we'll see that 40 times 40 is equal to 1,600, which means the square root of 1,600 is actually 40, which tells me the side length here of E is 40 millimeters. That's all for now on using or more about Pythagorean Theorem and right triangles. If you want to rewatch any part of this video, please do. Just rewind any part and rewatch whatever you need to. That's all for now. I'll talk to you later.